Okay, the moment that you see Bernoulli's equation, you're going to say, whoa, this is the wrong course. This is for fluid mechanics. Yes, I do teach fluid mechanics, but I still have Bernoulli's equation, which is just as a side item. This is one of the most commonly used equations in fluid mechanics, but it is a particular equation where here is what the equation looks like. He solved this equation. F of x times y to the power of n. One thing is, what happens if n is equal to 0? That's a linear equation right there. What about n is equal to 1? You may think that, hey, this is not linear because I see y on the right hand side, but note that then I'm going to get y and I can move this to this side, right? So px minus fx, I can call it another function. So this becomes a homogeneous linear equation. And what he recommends us to do is just use this particular substitution, okay? And when you do this particular substitution, you will find out that it will reduces it to a linear equation, okay? One thing is, I see sometimes, not that this is 1 minus n. Sometimes I see students using, let's say n is 5, they use 4 here. That's not quite right, right? 1 minus n, not n minus 1. I think the best thing to do for the Bernoulli's equation is to illustrate this with an example. So I'm going to just pick an arbitrary, function. So let's write dy. Well, it's not that arbitrary. It needs to be in this form. Minus 1 plus x times y is equal to xy squared. The first thing that you see here, this is an x, so I have to divide both sides by x. Then I get myself dy dx minus, now let's write this, 1 plus 1 over x y is equal to y squared. So now you kind of see, right? It's like clearly that I have my f of x is equal to 1 and I have my n is equal to 2. So what about my substitution? Well, it's right here, right? So I will do this. U is equal to y 1 minus 2, or that is going to be y to the power of minus 1. It's kind of, just want to highlight, most of the cases when I did Bernoulli's equation, I get something like this, but I usually don't have 1 over y. So I kind of flip this around and I say y is equal to u to the power of minus 1, right? So I can say that, right? So this is actually much more, useful for me. So if I go ahead and write this, and I'm going to use this version of the formula, I will get myself d, well, it's going to be u minus 1, right? That's why. Dx will be equal to, actually I want to just go ahead and solve this right there and then and continue my equation because this seems a bit tricky. So it's going to be actually minus u minus 2, do you see that? I'm taking derivative with respect to x, du dx. Okay, so that's what I have for here. So once I have this, I'm going to plug this in because it looks much more manageable now. Du dx minus, same thing, 1 plus 1 by x, u minus 1, which is y, is equal to u minus 2. I have a bunch of u minus 2's. So what I'm going to do is, if you remember the linear equation definition, so I need to divide by this whole thing. And I will get myself du dx plus y plus, because I'm dividing by minus u minus 2, right? 1 plus 1 by x times, if I divide this by u minus 2, so I'm multiplying by u squared. So I get myself u squared, and the right hand side becomes minus. So now this is a linear equation, you see that, right? This is a linear equation, and actually the rest of the question we practiced many times, okay? So it's nothing too difficult. But just for completeness purpose, let me solve it for you, so we can, say that I solved the question for you. So integration factor, remember that p dx, right? That's what my integration factor is. So if I go ahead and do this, so e to the power of dx, that's going to be x plus 1 over f, so that's going to be ln x, right? So I think I almost remember I had this kind of integration factor in one of the videos. E to the ln x, right? E to the x times e to the ln x. So this is going to be x times e to the x. Yeah, I remember this. I'm almost certain. So then I'm going to multiply the entire equation by x times e to the x. So let's do it. So it's going to be ex e to the x du dx plus, I'm simply copy pasting, x u to the x 1 plus 1 by x times u is equal to minus x e to the x. Let's not forget the minus. So then, if you remember the rule that we have established, the left hand side will be always the multiplication of the integration factor and the dependent variable, and in this particular case the dependent variable is u, right? That's what I'm going to get. The right hand side, the integral of that will be, okay, I think I need to do integration by parts, so let's do integral u dv is equal to uv minus v du, right? So I'm going to call this u is equal to minus x, so I'm going to have du is equal to minus dx, right? Let's not forget the minus. The remaining will be the dv, which is going to be e to the x times dx. So from here, v is equal to going to be e to the power of x. And I said that memorize this. Do you remember that? X times e to the power of x. So I'm going to get myself minus x e to the x. There's a minus, minus becomes plus, and I have an integral of e to the x dx. So that's going to be e to the x, right? And I have an integration constant of c. Okay. So then I'm kind of done, because obviously, you know, u is 1 over y, right? So I'm going to insert that. So x e to the x by y will be equal to minus x e to the x plus e to the x plus the integration constant of c. So, okay. So let's see. I'm going to divide everything by x e to the x. The left hand side I want to leave as 1 over y. So that's going to be minus 1 plus 1 over x plus c by x e to the minus x. I think that's pretty much it, right? So I don't think I can proceed any further than this. Okay, let's go ahead and solve this initial value problem. The first thing I have to do is I have to leave this one alone. So I have to divide both sides of the equation by square root of y, right? So if I do that, I will get myself dy dx plus, let me see for a second, y, right? 3 half minus 1 half is, 1. Is equal to, well, y to the minus 1 half. So now you can clearly see that this is a Bernoulli's equation, right? I have my p of x is 1, f of x is 1, and n is minus 1 half, right? So then I will need to do the substitution this way. U will be equal to y, not n minus 1, 1 minus n. So as this is minus 1 half, so then this becomes y to the power of 3, 1 half, right? U. So I cannot really plug u because there's no u in the question, but rather there's a y, so I have to flip this around, so I will have y is equal to u to the power of 2/3, right? Then plug it in, but rather let's let's calculate this dx of y is u 2/3. Let me double check this. So the derivative of this is going to be 2/3 times 2/3 minus 1 is minus 1/3, right? U minus 1/3 du dx. Okay, so this is the first term. So I can simply then write it. The rest should be fairly manageable. U minus 1/3 du dx plus, well, I have myself y, so that will be u to the power of 2/3, right? That's what I'm inserting. Will be equal to u to the power of 2/3 to the power of minus 1 half. Let's rewrite this one more time. U minus 1/3 du dx plus u 2/3 will be equal to u to the minus 1/3. Now I will multiply both sides of the equation by times u to the power of 1/3 so that I can leave this alone, because in the linear I should have just 1 over here. If I do that, I will get myself 2/3, well, that is actually du dx plus 3/3 times u 2 by 3 plus 1 by 3 is 1. So I get myself u is equal to u 1/3 cancel each other. I guess I have myself 3/2. So this is definitely linear, actually on the easier side, right? So this time around I get myself px is equal to 3 by 2. So that seems fairly easy to find the integration factor then. As it's a linear equation, I multiply this by e to the power of 3 by 2 dx. I will get myself e to the power of 3x by 2. Okay, and I'll multiply both sides by that, e to the power of 3x by 2 times du dx plus e 3x by 2 times 3/3 times u will be equal to 3 by 2 e to the 3x by 2. Just like always, the left hand side will be ddx of e to the 3x by 2 times u, and the right hand side will be 3 by 2 e to the 3x by 2. Then obviously I'm going to take the integral of both sides. I'll get myself 3x by 2 times u. Integral of e, so that's going to be 2/3 of e to the 3x by 2. Remember, you're taking integral, not derivative, plus integration constant of c. So you can see these two cancel, right? So you can see in here, so if I divide everything by 3x by 2, so that seems very nice. I like it. U is equal to 1 plus c times e to the minus 3x by 2. I think time has come to insert, what u was. If I'm not mistaken, u was y 3 by 2. Let's double check that because I really don't want to solve this again. Yep, exactly. So I'm good. So if I put this in, I will get myself y 3 by 2 is equal to 1 plus c e to the minus 3x by 2. I have an initial condition. Let's find what the c is. So I was given that y 0 is equal to 4. Do you understand from here, right? Just to confirm. So this is the x value, this is the y value, right? That's how it's written. So this is x, and that's y. Y is 4, so that's going to be 4. 3 by 2 will be equal to 1 plus c times e to the 0, right? So this is 1. So what is this 4 to the power? So square root of 4 is 2 to the power of 3 is 8. So you can see 8 is equal to 1 plus c. So c is 7, right? So if I then go ahead and write this, so y to the power of 3 by 2 will be equal to 1 plus 7 e to the minus 3x by 2. Okay? So this kind of does it for the Bernoulli's equation section. I'll be back with another way that we were doing at substitution. Okay? Thank you for the attention.